it. All right, and I've got my normal slide here. All right, can you see the slides on the other side? I think I muted you, but okay, I assume you can. All right, so welcome everyone. Thanks for joining our August meeting. This is the first of our getting back to in-person meetings, but obviously we're doing it hybrid. So for some of us online, some of us in person. So this is the first time we've tried this, so we're working it out. So bear with us and we'll try and make it work, but hopefully it's going to be it's going to work for majority of us to choose whether you want to attend in person or online and whatever works for you. So tonight's main topic, we've got Hank and Ken are going to be co-presenting a topic on 3D printing. We should probably do our normal club business to get started. I don't think Jojo's on, is he? Oh, he just joined actually, yeah. Let me see. Hey Jojo, I was just asking if you were on. It looks like you just joined. So are you able to present if I bring up your slide?
Oh yes, good evening, Kevin. I will be.
That was good timing. Here we go. Let me bring it up.
Yep, thank you very much.
My eyes are so out of focus. I know.
All right, ready when you are.
Okay, let me just get to my screen here. Okay, good evening. This is Jojo, and I am the club treasurer presenting our general membership meeting report for tonight. For the number of members that we have, it's currently standing at 190, and we are 68% paid up for this year. As early as September, we will be welcoming your early renewals for the year 2023. So welcome to our newest member, that is Charles or Chuck, and he is our new representative to the Daily Noontime VHF Net. For those who are not aware, the Daily Noontime VHF Net happens every 12 noon, and that's all throughout the year since I think 1980s. So that is sponsored by the Sacramento Radio Club, and it's an all-volunteer radio club where we make sure we are on operational readiness during emergencies. So please tune into W6AK repeater to listen and check from the repeater book for information. You can contact the club if interested to join. I'm a member of that. Can you move the slide up, please? Thank you very much, Kevin. For the treasury, our bank balance is 9,207.50. So we have disbursed the checks for 3 expenses. Those are the food expense during the field day, the in-person meeting reservation for club meetings at VFW, and a repeater maintenance cost with a total of 1,025.43. So we will subtract that once the checks clear from the 9,207.50. With that amount, our repeater fund is at 3,090.64. So thank you very much to all members who have renewed and all the evergreen donors. I added an agenda item. This is an announcement that I have running GMRS repeater in Sacramento. It's called SAC 725. You can check it out at mygmrs.com. It is intended for teaching radio to non-hams, but otherwise GMRS license holders, or they can begin with FRS, and to serve as neighborhood radio watch program in partnership with SAC Sheriff Sharp. They are in dire need of membership as well. So let me know if you are interested. The last activity they promoted is to watch over cars for thefts, break-ins, and other crimes during the Cal Expo or California State Fair. That's our recent event. So if there are no other questions, thank you very much. This is Jojo, KN6HTV. Thank you, Kevin.
All right. Thanks, Jojo. All right. Normally we ask Carol to do a club website and social media update as well. Is Carol there in the room with you guys?
No.
Okay. All right. She's not online either. So we'll skip that for this week. All right. Before we get started on the main topic, then, are there any other news items or items of interest? All right. If not, we can hand over to Hank and Ken. Which one of you guys is going first?
How come Hank's in the middle of the street?
Yeah.
Muted. Your audio's muted, Hank.
And it's hot out here.
There you go.
Who's outside?
It's cool down here. It should be here.
It's nice.
All right. Hank, are you going
I don't-
first or is Ken going first?
Yeah, I can go first. I don't
Okay.
see Ken anymore.
There
But how do I do this? I click on share screen
Yep.
and then I have to start the PowerPoint application.
Yeah.
Well, that's not it. Interesting. How do I get out of this? Well, when I click on share screen, that's what I get.
Does it give
Oh,
you an
here it is.
option like to pick
got it.
the desktop?
I got it.
Oh, there we
I
go.
got it. I got it. I got it. There we go.
There you go. Looks good.
Okay, here we go. My presentation this evening is on 3D printing. I'm by no means an expert. I'm a novice. And I just thought that I'd give some details on how this all works and what it's all about. Start off a little 3D background. 3D printing was first mentioned in the 1940s and the 1950s. The general concept and procedures to be used in 3D printing was first described by Murray Leinster in his 1945 short story, Things Pass By. It was also described by Raymond F. Jones in his story, Tools of the Trade. Published in the November 1950 issue of Astounding Science Fiction magazine. It's interesting that this started out in science fiction. He referred to it as a molecular spray in that story. It was first developed in April 1980 by Hideo Kodama at Nagoya, Japan, Municipal Industrial Research Institute. He invented two additive methods for fabricating three-dimensional plastic models with photo-hardening thermal-set polymer, where the UV exposure area is controlled by a mask pattern or by a scanning fiber transmitter. He filed a patent for the XYZ plotter, which was published on 10 November 1981. His research results as journal papers were published in April and November 1981. What's interesting about it is that when he presented this to his organization, there was no interest in it. Okay, types of 3D printing. There's SLA, which is stereolithography. SLA produces extremely accurate and high resolution parts. There's SLS 3D printing, which is selective laser sintering. SLS is one of the most inexpensive operations for industrial 3D printing. There's FDM 3D printing, which is fused deposition modeling. FDM produces rigid parts with speed, accuracy, and competitive costs. FDM is a type most often used by hobbyists like me. Then there's DLP, which is digital light processing, HP, multi-jet fusion, polyjet, DMLS, electron beam melding, and a jillion others. Some types of commercial plastic resin that we use. One is PLA, which is polylactic acid. It's easy to work with, probably one of the most popular with hobbyists. It's made from vegetable products. It's food safe, but you need to refer to the manufacturer for guidelines. ABS, everybody knows what ABS is. It's very tough, but it's not food safe. Little feedback. Okay, there's PET, which is polyethylene terephthalate. This is the same plastic that milk bottles are made of. It is food safe. There's TPE, TPU, and TPC. These are all flexible, but not food safe. There's nylon, which has high strength. It is food safe, and also it's machinable. Polycarbonate, very high strength, not food safe. You can also have wood-filled, metal-filled, conductive.
Looking for slides. Change to the picture. Change.
Conductive glow in the dark, magnetic, color changing. It changes by heat. Clay fiber, which can be fired, glass fiber, carbon fiber, and many others. None of these are food safe. Plastic resin, also known as filament, are available in many colors and properties, such as glow in the dark, color changing with temperature, and others. Most of these filaments are relatively inexpensive, on the order of about $25 per 2 kilogram roll. That equates to, I'm sorry, 1 kilogram roll. That equates to about 938 feet. Here's a picture of some types of filaments. ABS and PLA is what I'm using right now. Firmware and software. There are a number of software products called slicers that generate the commands, which are called G codes, necessary to control the 3D printers. They're available for purchase as well as free open source products available on the internet. Other products for designing models are available, such as Autodesk Fusion 360 and Tinkercad. Another free product is Octoprint, a software that permits complete control of the printer, either direct connect via USB cables, Ethernet over a local area network, or over the www internet. G-code commands in 3D printing are similar to the G-code instructions used in CNC machining. And because we're working with melting plastic in temperatures as high as 250 to 350 degrees Celsius or more, and some complicated projects may take many hours or even days to print, care must be taken using unattended remote access. You don't want to burn the place down. Also, filaments may be susceptible to cold drafts, and if used in unheated rooms, it may be necessary to enclose the printer to maintain build temperatures. Some printer materials are susceptible to moisture, so care should be taken to keep your material preferably in a dry box, which is a plastic box that contains a thermostatically controlled environment to help stop moisture from getting into the filament material. PLA in particular is hygroscopic. It sucks up moisture like crazy. Who uses 3D printing? The automotive industry has been charging ahead with additive manufacturing with high-profile companies such as Audi, Ford, Volvo, BMW, GM, and most recently Tesla. Even Jay Leno has a 3D printer in his garage. And I have a link to that if you want to see it, that he uses to create models for parts for antique cars that are no longer available. General manufacturing, it makes sense to make small, highly detailed models of cheap plastic first to see the product before spending thousands or even millions of dollars on multiple handmade models. It's used in robotics, education, hobbyists, medical, artificial hearts and other organs, prosthesis. Aerospace industry uses it, public libraries, and some public schools have 3D printers available for users and for students. How 3D printers work. The picture here is the printer that I have. It's a Creality. It's made in Japan. It can build models about 12 by 12 by 15 inches high. There are 3 axes on the printer, an X, a Y, and a Z. There is a heated extruder that the plastic filament passes through. It has a stepper motor that moves the extruder left to right on a gantry, that's the X-axis, and another stepper motor called an extruder that pushes the filament through a heated, normally 0.2 millimeter nozzle. The filament can also be retracted as necessary, as all of the stepper motors are bidirectional. And if you're not familiar with stepper motors, they're extremely accurate. They're making steps in fractions of a millimeter. The Z-axis, also called the gantry, can be raised and lowered by 1 or 2 stepper motors and jack screws back here. That raises this gantry here up and down. On one or both ends. On mine, I have it on both ends for stability. The build bed moves forward and back on the Y-axis. That's just down here. And the build bed is heated to help make the model stick, so it does not get damaged by the movement of the extruder nozzle. Some of these build beds are made of carborundum-coated glass to help maintain flatness. All 3 axes have stepper motors and limit switches under control of a simple microcontroller, which in turn is controlled by software instructions called G-codes, which are made by the slicers. Circles can be easily made as there are X and Y axes. Spheres can be easily made as there is the 3rd or Z axis. Thus, any shape can be made 1 layer at a time and actually make a ball. Even the least expensive 3D printers have amazing repeatability and precision movements down to fractions of a millimeter on all 3 axes. Commercially available hobbyist 3D printers. There are over 60 products available, starting at under $200 up to tens of thousands of dollars. Many are available from Amazon. Some popular brands are Creality, Prusa, MakerBot, Ultimaker, and many, many more. Most of these products come only partially assembled and so require some assembly by the end user. To maintain the repeatability as advertised, care must be taken when assembling to use the proper manufacturer's torque specifications on all the hardware. It is always prudent to use the German torque specifications known as good and tight, rather than SAE inch pounds. For the Chinese products, the Asian good enough specs may be used. Keep in mind, all of these products use small metric fasteners for assembly. Most of these kits come with a set of tools for assembling the printer. And that was shown on that last picture. Not all 3D printers are commercially manufactured. Gert and I have a friend of ours who is building his own right now. It'll end up being about 4 by 4 by 4 feet. Speed of printing. One of the restrictions for speed in 3D printing is the nozzle size. Currently, most nozzle diameters are 0.2 millimeters in diameter. Increasing the nozzle size to 1 millimeter diameter on a given model project can reduce the build time from about 3.5 hours to 1.7 hours, but at the penalty of poor resolution. So to an extent, the slower it moves, the finer the resolution. In the Cura slicer software, which is what I use, there are several resolutions that may be chosen, done by simply slowing down the print process. So some of the resolution loss can be made up to compensate for the larger nozzle diameters. You can get larger nozzle diameters, which will give you faster prints, but the resolution is not very good. Some 3D printer technology uses a metal powder called sintered metal. It's extruded through a nozzle to make direct metallic projects with no machining necessary. Okay, 3D printing as it applies to ham radio electronics. Some possible projects, accessories for ham radio equipment. Some examples, stands for small radios such as the Yellowcraft series, covers for the remote heads of Yaesu, ICOM, and other mobile radios, multiple outlets for Anderson power pole connectors. That's what this is. Fuse holders go in here, and the Anderson power pole connectors go in here. This fits on top of this and makes a nice little power distribution box. Power supply cases made from old PC power supplies. And I have some website pictures available for that, but not in this presentation. Insulated hardware pieces, project boxes and enclosures, ham call sign plaques. I made a deep cover to protect a Yaesu FTM 400DR remote that attaches to my motorcycle handlebars to help shade this radio, this APRS radio from the sun, so I can better see this LCD screen. It also protects the radio from rain. You always hit rain on a bike. Another use could be antenna parts such as insulators, balun housings, and coil forms, etc. Many hands are using Raspberry Pi single board computers. There are several 3D printed cases available. Just about any insulated container you would want is available. This is something that I made for Carol. She got the files for me, and I turned this out on my printer for her. Interesting. It's an interesting project. For those of you that haven't seen this yet, you should go to that site and read the presentation she made. It's very interesting. Okay, some modifications I have made to my printer. There's one. I built a desk to support my printer from 2 inexpensive IKEA cabinets I mounted on wheels. I bolted the cabinets together and added a plywood top service. These cabinets also have drawers and storage shelves for tools, spare parts, and filament. I made a miniature Arduino Wi-Fi camera to monitor the project while it is printing. It can be mounted anywhere on the printer, including the movable Z-axis, to permit seeing the model as it is made. When the weather warms up, I want to build a housing. Well, the weather has warmed up, but I want to build a housing out of clear plastic to hold the entire printer. That'll protect it from weather maintain a more constant heat. And I'll put this out on my patio because I've got outlets out there available, electrical outlets. I have a single board x86 based computer that runs Windows 10 with a 10-inch colored gimbal mounted monitor. I also run some software called Octoprint. That's a program that permits plugging the printer directly into a PC USB port for printer access and control on a machine code level. Some hobbyists use Raspberry Pi computers because they are so small and inexpensive. Originally, I was going to use one of my Raspberry Pis mounted to the back of this monitor, but I don't speak very good Raspberry Pi, so I didn't do that. That's kind of a close-up of the 10-inch screen that I'm using. And that's the 486 single board computer that I use. How to get 3D printer models? Well, you can do it from scanners. That's like a 3D camera. Most of these, you mount your model that you want to make on a platform that turns, and there's multiple cameras that take pictures, and you end up with a 3D picture after running it through some special software called a mesh mixer. There's free programs like those from Autodesk, such as Fusion 360, Tinkercad, AutoCAD, and others are just fine for hand-drawn or engineering models. Autodesk is the company that makes AutoCAD, a desktop product that has been around for many, many years and has become an industry standard in the engineering, drafting, and machining industry. There's free models available on the web. Thingiverse, STL Finder, Yagi, and many, many more have STL files already made up, ready to print. All you need to do is plug them into your printer. There's some websites where a hand talks about 3D printing. These are kind of interesting. There's more projects available here. I didn't want to take up too much time on listing everything though. In summary, pretty much anything that can be photographed or drawn isometrically can be reproduced on a 3D printer. My little hobbyist printer can print 300 by 300 by 400 millimeter, which is about 12 by 12 by 15 inch size sub objects. And some of the commercial printers can easily print car-sized models with movable parts such as doors, hoods, trunk lids, and even engines. I just saw, I didn't get a chance to include the URL in this presentation, but there is a university that built a house using a 3D printer, a very large 3D printer. And instead of using plastic, they used concrete. But it's controlled the same way with the same type of software and the same type of device for distributing the concrete. In researching information for this presentation, I discovered about 403,000 hits that are available on the internet. And I also stumbled on a pretty good book, my local library, titled 3D Printing for Dummies. My kind of book. Okay, and that ends my presentation. Are there any questions?
Well done, Hank.
Also, before I turn this over to Kevin for his, how do I get out of this now? There, okay. Screen sharing has stopped. Before I turn this over to Kevin, there is one more thing I'd like to say. In deference to Tom Cutter and his flamingo antenna, I've recently made one too on my 3D printer. This is multi-band, and it's based on the old-fashioned antenna system called, well, it's not a very good picture, rabbit ears. These are adjustable, so it's multi-band. Okay, enough of that.
That's awesome.
It's all yours.
I have a question.
Go on.
You mentioned the range of cost of printers. One similar to yours with the same capabilities minus the mods that you made. What is the price range nowadays on one of those?
On one, like my model,
Yeah, similar to yours.
okay. When I bought that, it was $450.
Okay. Thank you.
They start in price at about $200, and they go up to tens of thousands of dollars. This one's fine for what I want to do.
How, I have a question as well, this is Tom Cutter. How toxic are the fumes coming off your plastic as it's being developed?
If it's PLA, which is what I use, it is not toxic at all. If it's ABS or nylon or some of the other exotic materials, you want to have it outside. You don't want to be breathing the fumes.
Thanks.
I got a question.
What's that?
What do you use for UV rated plastic filament?
For what?
Ultraviolet? Putting a structure outside the sun.
I'm not aware of any ultraviolet plastic.
Yeah, yeah,
That is.
More toxic.
I suspect they are.
I can't
I
say
know.
a lot
Oh,
for
I know
myself.
that. I'm sorry.
Uh,
I know that.
Go ahead, Hank.
I know that some of these plastics, the sunlight doesn't bother them. Like ABS, nylon, the sunlight won't bother. PLA is okay for a while, but eventually it's gonna go bad if it's left outside all the time. But some of these other more exotic plastics like metallics and wood, those would last a long time outside, no problem. Okay, go ahead, Ken. Sorry.
On the PLA, I have a friend who prints in PLA for his outdoor garden railroading. And he says he's had no trouble with PLA being affected by ultraviolet. If you're really worried about it, you could paint them and that would protect it from the ultraviolet.
You can paint a lot of these models to the material will take paint, so you can protect the surface.
Right.
Oh, yeah.
Okay.
See, that's what's great about this, Ken. I learned something every time I talk to somebody about this. So that's good. I didn't know that. I'd always heard that the PLA didn't last very long outside.
Well, I can just tell you what this friend has told me.
Yeah.
All right.
Try.
Let me go to. Okay.
Screen sharing.
Yeah, wait a minute. Okay, share screen.
Yep.
All right. Okay.
Looks good.
That's you slideshow. All right. I'm going to be talking more about how you would design something in to use on a printer. I'm taking this from a YouTube video, 3D printing for ham radio by Kevin Logan. I don't know how to pronounce it. Like there, and this demo is being done using an online program called Tinkercad. This is a screenshot of the work surface. On the right hand side, you can see the various shapes that you can bring in. You just click on here and drag it onto the work plane. We're going to make a small angle bracket with this demonstration. First, you import a cube, and then using these, contacts, these little grabbers here, you flatten the cube, you bring it down and make it flat. Then you copy it and rotate it 90 degrees like this. Then you bring them together, and in the program you can add them together and it becomes one piece on the screen. Then you import a cylinder and drag it over and put it on the flat part and drop it down so that it extends all the way through the part. Then you copy it and bring it up and then move it over so that it is in the upright. Then you take those two parts and subtract them from the red, and you have two holes there, making an angle bracket. Now all you have to do is send it to the printer and print it. And using that procedure, you can design any number of items by adding other blocks, subtracting parts, and modifying them as you want. Some examples of what you can do. I've done a couple of these, others I took offline. So what was that? Okay, here is a center for a dipole having a balun on it and a connector for BNC. You print the blue part out and then use it. Here's a box to put a balun or unun in. You've got the hole for the connector and then a hole for the antenna part. Here is a inline volt amp meter that I built, that I printed out. You can make insulators for antennas. Here's a guy ring for a mast. Fiberglass mast, once you put them up, it's hard to get connections to them for guying them. There's a power pole breakout box. You print the one in black, one in red, and then you put the connectors on it. Can do nameplates. Any kind of printing can be done. You can make a stand for a handheld. In short, you can design and print any number of things for ham radio and other interests. I do some for my model railroading, and you can do it for other hobbies. All right, that's it.
That's pretty
Well
good.
done.
All
Tim,
right.
how strong are those parts printed out? Like that mast guy piece that you had, like how strong is it?
Moderately strong. I won't say it would you could hold a ton up with it, but it would work for most mass uses.
Okay,
And if you do break it, well, you print another one.
great.
Now, let's see, how do I get out of this?
Try moving the mouse up to the top, and then there's a stop sharing button that appears.
Oh, there we go.
There you go.
Okay, thank you.
Cool, thank you.
Kevin?
Yeah.
You ask how strong this stuff is. These are some strength samples that I printed out when I first got the printer. I was curious about how much strength they had in them. I don't know if you can see that or not. Can you see that?
Yep, we can see. Yep.
Can you see how that's honeycombed like?
Yeah.
Here's another example. Oh, what is going on with this?
There you go.
It's very strong. Either one of these things, you could easily set a car on them and it'd support it.
Whoa.
They're very strong, very tough.
Oh. How about food safe? Like, could you print things like bowls and spoons and things and use them for eating? Is the plastic toxic or is it safe?
Well, as Hank was saying, PLA would be food safe. ABS is not.
Okay.
So it depends on what you're using.
Yeah.
Right.
As a matter of fact, we have used some of the bowls that we've printed as chip bowls and that sort of thing with no problem. If I'm doing dip, I put them in something stainless because I want to be able to throw them in the dishwasher afterwards.
Right.
And then I just hand wash the bowls that have had, dry things in them. So
Yeah.
gently you can use them for food, but I wouldn't use them, I wouldn't serve an omelet in them or, you know what I mean?
Yep. Yeah.
They're not, and they don't go in the picnic basket for whatever, because you're not going to cut a steak or whatever on them, but they're okay for, just.
But then on the other hand, they're good for cold snacks.
Ah.
Either way, it's just the right size for a can or bottle, whichever.
Yeah.
So you can get a handle on it. And I put a piece of the bubble, like things come in the bubble wrap. I put a piece of that down in there to help keep the can cold. So works nicely.
That works. Yeah. Good.
I have a question. Obviously, for items that do not exist or you cannot obtain or they're specific, this is obviously the solution. For other items such as boxes and etc., what is how cost effective is for common items?
Well, if you've
Very
ever
good.
gone out to buy a project box and been told you got to pay, $12 or $15 for a piece of plastic, this stuff is pennies on the dollar to produce it. You just have to wait. So it's more a matter of designing it and being able to, put the holes where you want it and have it the size you want and so on. So it's
This
pretty
mug
cost
right
effective.
here, this mug right here that I printed a couple of months ago cost 74 cents
in material.
in material.
And
about,
thank you.
And about half that in electric power, because the 3D printer does have a heater in the nozzle on the thing. It runs off of 24 volts, but still it's power. You're using it. And it's on all the time that you're printing. So there will be some power usage costs involved, but not very much. Most of these projects print pretty quick anyway. Although I have printed some, like this one here. This took a couple of days to print. It's a castle. And for kids that play Dungeons and Dragons, you put your dice in here and it goes around, 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 falls on these steps and falls out here and stops right there. But
Way
this,
too much free time, Hank.
lot of detail in there, so it cost,
Takes a while.
I took about,
Yeah.
I think it was 28 hours or something like that to print.
I've got a question.
Yeah.
Does the plastic come in a clear form that you can see through so that you can make things similar to glass for enclosures?
Yes. They just come out with a new type of PLA that is crystal clear. It's like looking at glass.
Wow.
As for the colors that are available, there's probably maybe 50 or 60 different colors that you can get. Some of it is
the ability to see through some of that would probably be limited by the efficiency of the printer you're on. Most of the ones are less expensive, and you're going to see spirals from where it's done. It's not going to have a flat surface. It's not a molded surface. Remember, it's a poured or printed surface. If you've seen any videos of the houses that they use concrete to print, you see they've got surfaces. You're going to have that same sort of thing on a much smaller scale. That's sort of either to get the clarity through would probably require a much more expensive series of printers and plastic source.
Interesting. Thanks.
So it's probably not ideal for like wishing to look at a display through that clear plastic.
You
It's
know,
probably distort the image.
it's there. It comes down to reasonableness. Do you really want to print a screen that you can probably buy that's been professionally made and will last many years compared to?
I'm thinking more in terms of instead of trying to cut a fancy opening to fit one of these liquid crystal displays, you put it behind a clear plastic cover, and then you can read the display. It's much less intense than machining.
Your
process.
mileage may vary. Let's
Yeah.
put it that way.
Yeah, I think it'd be questionable.
Yeah.
Also, what's interesting about this is that because it does have such good repeatability and accuracy, you can print things like threads. I don't know if you can see that or not.
Hey,
Can you see that?
turn the background off, Hank.
It's
Bring it
actually,
in front
Oh, are you like machine threads?
Yeah.
yes, you can screw right together like that.
Wow.
That's a light bulb,
That's bolts.
light bulb bank.
Anyway,
But- And it's surprising, Phil, that it can even print thread sizes down to, I think, number 6, a 6 millimeter screw. That's pretty
That's
small.
actually fairly big, 6 millimeter.
yeah.
What? It's tiny.
You probably wouldn't pull off a 440.
No, probably not.
Number 6.
Well, no, 6 millimeters.
6 millimeters.
It's
Yeah.
1/4 inch.
Oh, I'm sorry, not 6 millimeter, M6,
M6.
like that. That's tiny.
Sweet.
And also, there's at least one company that has a 3D printer available that you can either 3D print on it, or you can add a router motor and do
Engraving.
engraving, or you can put the laser head on it and actually use it to burn things in other materials like leather and wood and metal and so on. But it uses the same thing. It's just like CNC machining. Everything you need is right there.
There you go. He just suggested we try it for tattoos. Do we have a volunteer?
Ouch.
Yes.
You did say burn, right?
Yeah. Oh,
Do any of the printers do multiple colors at a time? I think most of the things you printed are all a single color. Can any of them do multiple?
Yes, you
you
can.
can do multiple colors. Some of these printers, the more expensive ones, have multiple print heads on them. And you can print like 2 or 3 or 4 colors simultaneously.
Oh, wow.
Or like on mine, let me see if I got a sample here.
Yeah. What you do is you print one layer and then you change the
Filament.
filament
Okay.
and print a
Ah,
second
Well,
color.
that's what I had a sample here of that, Ken, but I think I gave it away. But it was a bowl that was silky white, and then it just merged into silky silver color by doing just what you say, by changing the filament.
okay.
And it, you can pause
stop
the print.
You can stop the print, and when you start it, you can't see it in the print itself. It's that good.
Wow.
It's surprisingly pretty accurate for what they cost and what it is, and just the basic design of the thing. But like I said, it's like anything else, you know, you can buy a $200 radio, or you could buy a $2,000 radio. Just
I have a question. I
Okay.
have a question. Where is it kind of like having a normal printer where you go to Fry's and get your ink cartridges, or are you going to be locked into a relationship with some online provider?
No, there's a lot of different places that sell the filament. The filament comes in rolls like this. Can you see that?
Bring it down.
Background interference.
Closer. Bring it closer, Hank.
Bring it down in front of you.
There. It comes in rolls like this. 1 kilogram, 2.2 pounds. It's about $25, and it comes in a jillion different colors and different textures. You can get rough, you can get smooth, you can get silky, you can get metallic colors like this, kind of a brassy color like that, and all different colors.
When Fry's was here, yes, you could go to Fry's and get rolls of filament and so on. We've been going to Amazon simply because it's the most convenient, but there are multiple vendors on Amazon that provide different brands and types of filament. And it does vary in terms of quality and color
Material.
availability, and we've noticed subtle differences in how it performs in the printer. So, you know, you'll change brands and just suddenly realize that you have to adjust your temperatures and your print speed a little bit, because the first time you use it, it messes up. It makes what we call spaghetti, because it'll stop sticking to itself, and because all the temperatures and movement are wrong for that filament. So there are variations, but for the most part, you're not stuck with just one vendor. You can go wherever you can find it online. And I would imagine, even though Fry's has gone to maybe some hobby stores and stuff that might have materials, you know, it's something you'd have to research online and see what's available. But
I think Worst Buy sells it, or Best Buy. sells
places
it.
like that. I'm not sure what other places have it.
There's gotta be a gazillion. Before COVID came, there was a gentleman down in Old Sac called Plug and Play 3D that could sell filament as well as machines. I don't know what it is, Simon. Well, no, he may not be around anymore. He was great. His name was Eric.
What's the name of the place?
Plug and Play 3D.
Okay, so we actually have a
I don't know if
local
it's still
vendor.
around or not. Great.
That's good. We'll
Very
have to try
helpful.
that place.
Very personable guy.
Be
The main
interesting.
reason that I like to use Amazon is because they have 20 or 30 different brands of filament. They've got all the colors that you want, and it almost always ships either the same day or the next day. So if you're really into something and you don't want to wait a week to get it or something like that, you know, that doorbell rings and there it is.
Yeah, it would be nice if we had a, you know, brick and mortar that was convenient, and, you know, to Kayla's point, it's nice to know what you're getting and where to get it and so on, you know.
That's it. That's what was good about Fry's before they went out of business. You could go in there and they had shelves full of this stuff.
Hank, are you about ready to move in a new house so you have enough room to store all these new models you built?
Oh,
No,
he just needs more friends because he keeps giving them away. They
I
don't
just gave away
accumulate.
a couple. I just gave away a couple of boxes of them. Some really nice vases and stuff.
What has gone, it would be interesting if both of you could put together a little bit of obviously you can't recommend things because people have different tastes, but if we recommend something based on your experience, if you want to do this is the range of equipment or material that you need, or the type of software that you should look at. As provided here, there are so many, and the choices are so many. If somebody trying to start would be difficult, we could profit from some guidance from you guys.
Yeah,
Well,
I think
no-
what we
it's-
need is the way we do with the radio, and I'm sure somewhere there is one. There's got to be a 3D printers club in the area where people put their heads together, because whenever there's an interest, there's a group of people that say, how did you do it? Or how did you solve that problem? You know, there's knitters guilds, weavers guilds, and so on. So I imagine that if we don't have one, we should start one, a 3D printing, you know, group, because it would be invaluable to the people who are interested.
Or
in
a
getting started.
segment of our club that could be dedicated to that, like we have for builds and do-it-yourself items.
Yeah.
Thank
Yeah,
you very
just
much.
like we have the DIY group that's a subgroup of our membership.
You know, this groups.io thing, there is a group for everything. You'll probably find 50 of them, 100.
Yeah,
Yeah.
that's right.
I'll tell you one thing, overall, the one group that most of us have access to and belong to one way or another is YouTube, because thank God for YouTube. There is so much out there. The only thing bad about it is that, you know, it's more like a candy store. You go into it and it's overwhelmingly there, you know, and it's more a matter of choices and so on. It's a real rabbit hole to go down, but it certainly provides for a lot of us the starting point for how to and where to. Hey, Hank, why don't you turn the background off and make it easy?
Kevin?
How to do that. Turn
Are
it
you there,
on.
Kevin?
Yeah.
We're gonna have to shut down no later than about 8:45 because we have to be out of here by 9.
Okay, got it. All right.
So, yeah, so we got 16 minutes of yammer yet. But, anyway.
Did you have something else you're going to show us, Hank, there?
Hank.
Yeah.
Was you going to show us something? Oh, there you go. Okay.
Some roses.
It prints
These are made
roses.
so that you push the flower in there and it locks it in so it doesn't fall over because it's flexible.
Yeah, so you can do an arrangement that holds itself in place. There is just so much out there for you know, imagination to take hold. Also, somebody said earlier today that all of us are born with the talent to be creative, and the rest of it is a matter of learning how to use it.
Kevin, you'd like something like this. This is a camera. It's Wi-Fi. It's got 2 Arduino boards in there. One's a camera board and
Hold
the
it
other
up
one's
more.
a board.
Up, honey.
What?
Up higher. It's not on screen.
Yeah, that's right there. You can see it.
We can't.
I can see it.
Yeah,
Hold it in front of your shirt.
yeah.
There it is.
There you go. Better, much better. Yeah.
But anyway, this thing is so tiny, and I 3D printed the case for it. And then the circuit boards just fit inside of it. And then you can just hang it up on the printer, or you can stick it on with Velcro on the back, stick it on something. And it works pretty good. I can't, when the machine is printing, it's hard to get down there to see exactly what's going on. And my eyes are bad anyway. So being able to pick it up with a camera and put it on even a 10-inch screen is good. And on a 27-inch screen, like on my desktop here, it's really good. So that's what I do.
Yeah.
And it goes back and forth, and that goes back and forth.
By the way, Hank, how noisy is it?
It doesn't make any noise.
It's not bad at all. If you're not right next to it, you can't hear it.
Now, if you walk 3 or 4 feet away from it, you don't hear it. It just sits there and runs. I let it run overnight because the PLA doesn't create any fumes or anything. And I'm not concerned with it, any danger or anything because of the heat, because there's all kinds of sensors on this thing. And if the heat goes beyond what you set it for, it immediately shuts everything off, so that there's no danger of burning the house down or something. But I've done several projects where I let them run overnight because they take so many hours to do. And that's although you can pause a project and then pick it up later on in time, I just I'd rather let it go until, start to finish. Okay.
Is there anything else? Any other questions?
I've got another question. I think I might have lost attention when you were talking about cameras used to create the software to build something that
3D.
the 3D model. Like if you've got a little gizmo at home that's broken and you want to make one, replicate it, how easy is that part to do?
It's not really that hard. There's actually a website, and if you're interested in it, I can find the URL for it. But a guy took a cell phone and just walked around the model and took pictures of it. Hundreds of pictures. Ran them through this software program called Mesh Mixer, I think was the name of it. And that somehow assembles all of this stuff into a 3D image that you can run through your slicer. The slicer creates the G code that's necessary to control the printer. And then the thing works. And apparently he's very successful with it. It's on the internet.
Great, thank you.
The best part about this whole thing is that so much of this 3D printing is open source. You don't have to pay for the software. You don't have to pay for the models. You don't have to pay for advice. There's all kinds of stuff on YouTube from different groups and clubs and people. And there's actually people making money off of these things. One guy in particular I was thinking of, has a whole room full of these printers, and he makes these projects, and some of them are really complicated. One in particular that I can think of was a sundial that has a digital readout.
Cool.
Because of the shapes that are cut in the flat plastic that this thing is made out of, the angle the sun comes through, it actually displays the digit.
Is it done in Roman characters?
X's and I's, IVX.
And anyway, that was one thing. Another guy makes clocks out of 3D parts, makes gears and hands and all kinds of things. And these models are really those he sells. You know, he sells either the code or he sells the finished product. But it's kind of interesting. It's like anything else, you know, you can do as much or as little as you want with it.
Kevin, I think we're at the point where we're gonna have to start tearing things down.
All right, sounds good.
I saw a clarinet that a woman printed as her senior high school project. Full-size
Yeah.
clarinet that worked.
Well,
Yes,
Wow.
yes. I created a
Recorder.
a recorder for a granddaughter that worked.
Wow.
Hey, Phil, is the next meeting going to be at the VFW?
We're set to be here through November.
Okay,
Okay.
cool.
And we've got room for a lot of folks. I didn't get a head count yet. What do you think we're at? 10, 15, 15 people?
It was 12, 13.
13. And you know, in our old days, we typically had 30, 35 attendees. This was a little unusual because both our presenters were via Zoom. And it seems kind of ridiculous to have a meeting where everybody's on Zoom and we're sitting here watching Zoom. But yeah, we're here through November. And then of course, the month of December, we're gonna have our Christmas dinner thing again. So we're covered for the next 4 months.
So we
And
did
Sam's-
11 on Zoom. That makes 23 people. That's not too bad for hybrid.
maybe we ought to talk about the time to.
Oh, by the way, when we first set this up, I sent out a note to the board that I suggested we start these meetings at 7 because we have to leave here by 9 and we have to put everything away before we can leave.
Yeah.
Yeah.
So the start time at 7:30 is probably not going to happen for the next one.
Yeah. 7
It's
sounds
just
better
too
with,
tight.
Okay, sounds good. Yes, we'll do that for the next one.
you know what else
All
we
right.
didn't talk about that we talked about at the board meeting was the coffee meet. The meeting up for coffee between board meeting and club meeting.
Yes.
So where did, if, when, where?
Well, I haven't set that up. You know, there were 2 things we talked about. One was, you know, we pick a spot to have coffee. The other option was to pick a spot to have breakfast. And I'm kind of leaning towards the breakfast thing.
Mhm.
I think it might prove to be a little more popular, but it's going to be a trial thing. And I think I mentioned when we were talking about this, that the Napa Club that I was once a member of, that breakfast thing was great.
Yeah.
We had anywhere from 6 to 16 people show up, and it's a much smaller club. We got 190 members in this club, but it's a
Yeah.
great
Yeah.
chance for people to get together, banter things around. You got a little bit of time, so we'll play with that a little bit. And the other thing that should be mentioned is our QSL cards came in, and they're gorgeous.
Okay.
Alan Kenner actually donated them to the club, and it features our logo. The front of the card is our logo with the critters in the boat,
The ARCs.
the arc with the beam,
Yeah.
and they turned out great. So We got to figure out who's going to be the official QSL recipient guy. We do have one we have to send out as a result of one of our QSOs for field day. And I'm sure we must have some information so that we can fill in our report to him or his report to us on RST. So we got a few things going.
Yeah.
Sounds interesting. We thought of having breakfast with a ham.
Oh, that's bad. What about the eggs?
We provide the ham, they bring the egg.
All right, shut us off.
All right, sounds good. Thanks, everyone.
All right.
Okay.
Thank you.
Thanks,
Have
Hank.
a
Thanks,
good
Ken,
one.
for presenting. All right,
Everybody
thanks.
see that?